All right, Mr. Ahmed here for 5.4. Goal for today is to use isosceles and equilateral triangle theorems. So our essential question is really, how can I use isosceles and equilateral triangles? So our isosceles and our equilateral triangles have some special characteristics that these theorems are going to tell us. Before we get to that, we really need to identify just a couple key things of the isosceles triangle, its parts, and the definitions that we will be using. So an isosceles triangle, keep in mind, is a triangle that has at least two congruent sides. So I'm going to mark my two sides congruent with a tick mark, okay? Now it also could have three, but we're going to focus on two. The legs are the two congruent sides. So that would mean if these two sides are congruent, we'd have a leg and we would have a leg. The vertex angle is the angle that's formed by the legs. So here's my congruent sides again. So this angle here up at the top in this instance, it's in between the two congruent parts. That is the vertex angle. Now, the vertex angle is not always going to be at the top, all right? If I would have marked these two legs as congruent, the vertex angle would be down here. So you have to look for those congruent pieces. The base is the side of an isosceles triangle that is not necessarily congruent. That'd be about the easiest way to define it. So in this case, I'd have congruent, congruent. So this would be the base. Notice the way I drew this one. I switched it up. I didn't mark the two top ones as congruent because I don't want you to always think that the base is what it is sitting on. The base of the isosceles triangle, like we said, is the side that's not congruent to the other two, okay? And the base angles are the two angles that are adjacent to the base, and they are also opposite the congruent sides. So again, I'm going to draw this so that the base is not at the bottom. So here's my two congruent sides. So these two angles, bam and bam, those would be the base angles in this diagram. So they're adjacent to the base, they're opposite the congruent sides. When we say they're opposite the congruent sides, if I look at the congruent side, if I go to the opposite angle, that's opposite, opposite, all right? So those are our key definitions. We have legs, the vertex angles formed by the legs. The base is the side that's not congruent, and the base angles are the angles that are adjacent to the base, or they're the two angles that are opposite the congruent sides. So, first example says, which side is the base? So, notice again, it's not always sitting on the base. Congruent, congruent, the side that's the base has to be AC. So, AC is the base. In this case, EF is the base. And the last one, HI is the base because it's not congruent to the other two sides. So we've named the bases. An equilateral triangle is a triangle that has three congruent sides. Now, a couple key things here. Since this triangle is equilateral, it is also isosceles because isosceles triangles have two. This one has two congruent sides too. So an equilateral triangle will carry all the characteristics of the isosceles. It'll have all the same theorems as well. So our first theorem is the base angle theorem, and it states if two sides of a triangle are congruent, so I'm going to mark these two sides congruent, then in red, the two base angles or the angles opposite them are congruent. So since it had two congruent sides, it also has two congruent angles. So I could keep those tick marks there. And the converse of that directly states that if two angles of a triangle are congruent, so if it has two congruent angles, then the sides opposite them are congruent. in red. Okay, and the sides opposite them. So opposite across, opposite across. These two angles are congruent, and the base angles are still also congruent. Okay, so recap. If a triangle has two congruent sides, then it also has two congruent angles. And it's the angles that are opposite those congruent sides. So to get opposite, you would go across. Opposite, across. In a similar manner, if a triangle has two congruent angles, then the sides opposite those angles are also congruent. And you could also call that the legs. So I could phrase this a couple different ways. I could say if a triangle is isosceles, then the base angles are congruent. I could state if the base angles are congruent, then the triangle is isosceles. So I kind of like just phrasing it with the opposite sides piece. It keeps it a bit more straightforward. So just keep in mind, two congruent angles, two congruent sides. Two congruent sides has to have two congruent angles. And finally, the corollary goes for our equilateral triangles. A corollary is a theorem that's just super easy to prove based off a different theorem. So really, it states if a triangle is equilateral, equilateral means three congruent sides. So if it has three congruent sides, then it must have three congruent angles. So if it's equilateral, it's equiangular. So all three angles are congruent. Now, a couple pieces here. If all three angles are congruent, we know they add up to 180. 180 divided by 3 is 60. So that means each one of these angles is always 60 degrees in an equilateral triangle. The sides are not 60. The angles are 60. And the converse just states if a triangle is equiangular, so if it has three congruent angles, then it also has three congruent sides. So it goes both ways here. So an equilateral triangle has three congruent angles, and it also has three congruent sides. All right, so that's what we got cooking there. A couple example problems says, find the measures of angle R, S, and T. So when I look at this triangle, it's kind of a tricky question. No angles are given. However, 3 meters, 3 meters, 3 meters, these are all the same size. Therefore, it's equilateral. If it's equilateral, that means it's equiangular. So all three angles are congruent. So each angle is how much? 180 divided by 3 is 60, 60, and 60. So they're all 60 degrees. Okay? Find the missing value. First step. Triangle has two congruent sides. Tick mark, tick mark. If the sides are congruent, then the angles opposite them are congruent. So we have a 70 and a 70. This time I see two congruent angles. If we have two congruent angles, then we have two congruent sides. So our missing side has to be 18. It's an isosceles triangle. This one, two congruent angles. So two congruent sides. Mark it with the tick mark. 15 equals 4x plus 3. Have to solve it. 12 equals 4x, and x is equal to 3. Okay, next one. Two congruent angles, so we have two congruent sides. Now, careful which sides are congruent. Opposite and opposite. So these two sides are congruent. So I'd have to say 28 is equal to 9x minus 8. When we solve, add our 8, 36 equals 9x, x is equal to 4. X is equal to 4. All right, next one, 5x. No angles are listed. Each side is 10. So if each side is 10, it's an equilateral triangle. All three angles are congruent. So that means we have a 60, and a 60. So 5x is equal to 60. 60 divided by 5 is 12. So x is 12. All right, that's it for today. I'm going to go into another video with some more difficult equilateral and isosceles triangle problems for part 2. Have a good one.